Good afternoon, students. Today we'll see something about Cartesian products. Now I'll define what Cartesian product of a set is. Cartesian product of two non-empty sets is a set of ordered pairs. I'll show you an example and later on we'll be able to understand how this Cartesian product is going to be used in relations and functions. So let me take up two sets. Let's name the set as M and N, and let's consider the elements to be present in the two sets as 2, 4 and 5, 10. So I want to find the Cartesian product of M and N. A Cartesian product is also called a cross product. So how will we represent it mathematically? It is represented like this: M cross N. So the Cartesian product of two non-empty sets is once again a set. And the elements within the set are ordered pairs. Now how will this elements be ordered pair will be formed? Considering the first element from set M and the second component from set N. So the first ordered pair will be 2, 5. Likewise, I will frame another ordered pair also with the first element of set M. So 2, 10. So I have finished with the elements in set N. So once again moving on to set M and considering the second element. The second element is 4. So once again I am going to do a pairing. So 4 is paired with 5. Likewise 4 is paired with 10. So let's just look at this example. We have made a pairing of every element of set M with every element of set N. That is called the Cartesian product of M cross N. It is also cross product. Okay, to generalize this definition, I am going to write it in the set builder form. Just look at how I am writing this. So M cross N is a Cartesian product of the two non-empty sets. It is a set. It is a set of ordered pairs, say A, B, such that it is a set of ordered pairs. Let's take it as generalizing it as A, B. Where does A come from? A is an element of set M and B is an element of set N. This is a generalized, say, notation of a Cartesian product in set builder form. Moving on to find out the cardinality of the Cartesian product set. Now we are going to find out the cardinality of the Cartesian product of two non-empty sets. How do we define cardinality? Cardinality of a particular set is equal to the number of elements present in that set. So for example, what is the cardinality of set M? How do we write it? We write it like this. We represent it like this. So N of M is equal to, how many elements does set M have? Set M has 2 elements, and therefore the cardinality of set M is equal to 2. Likewise, the cardinality of set N is represented like this mathematically, and once again the number of elements present in set N is equal to 2, and therefore the cardinality of set N is equal to 2. Now in the previous slide we saw what was cardinality, what was the Cartesian product of set M and N, and you notice that it had 4 members. 4 members. Clear? How did we get this? So, now we are going to find out the cardinality of the Cartesian product of the two non-empty sets. The cardinality of M cross N is equal to, I am writing you the formula, cardinality of set M into cardinality of set N. Now what is the cardinality of set M? It is 2 cross, what is the cardinality of set N? It is 2 in this example. So what will be the answer? It is 4. So what do you understand? The cardinality of the Cartesian product of two sets is equal to the cardinality of that particular set M into the cardinality of set N. To generalize this, how can we generalize this? So let's take up, since my board is say a little smaller, I will just show it here. Let's say I am generalizing it. Let's say the cardinality of a particular set is Q and the cardinality of the second set is P. Therefore, the cardinality of the two sets, say M cross N, is equal to, what is it? Q into P, which is equal to QP. So this is the general formula for finding the cardinality of a particular Cartesian product of two sets. Okay. Is it possible for us to find out the Cartesian product of many sets? Yes. I considered only two sets here, right? Now, it is possible for you to consider more than two sets and find out the Cartesian product of those sets. So, in general, we call it an n-ary Cartesian product. So, they are going to find out the Cartesian product of n sets, x1, x2 and goes up to xn. So, how will the elements within the set appear? The elements within the set will be of n tuples. Okay? When we considered only two sets, the Cartesian product of the two sets had only ordered pairs. So the elements had only pair of, say, elements from both the sets. But here, the number of elements present will be n tuples. Moving on to the next definition. I told you we can find out the Cartesian product of M cross N. Is it possible for us to find out the Cartesian product of N cross M? Yes, that is also possible. The next question you should ask is, are the Cartesian product of M cross N and N cross N the same, the similar? Are the elements within the particular set, are they same? Let's just check it out. Now, Cartesian product of M cross N for this example will have the elements, namely 2, 5, 2, 10, 4, 5 and 4, 10. Am I right? Now what is, say, N cross M? We want to find out the Cartesian product of N cross M. Now how will the elements appear? The elements within the set will look like this. I should consider the first element from set N because I have written it at the front. Therefore, my first element of the ordered pair will come from set N. So it is 5, 2, then 5, 4, moving on to the second element, it is 10, 2 and 10, 4. Compare both the examples. You see that the ordered pairs are not the same. So what do we conclude? The Cartesian product of M cross N is not equal to the Cartesian product of M cross M. So finally, what do we conclude? Cartesian products, okay, are not commutative. Cartesian product of two non-empty sets is not commutative. Is not commutative. You already know what is commutative property. When you want to check for a commutative property, you will consider only two elements, two sets, right? And therefore Cartesian product is not commutative. Likewise, Cartesian product is not associative also. Okay students, now we are going to study the distributive property. What does a distributive property say? A distributive property says it involves three sets. Okay? So now we are going to find out the distributive property of Cartesian products over union as well as the distributive property of Cartesian products over intersection. So how do we mathematically represent the distributive property of Cartesian products over union? Just look at this example. This is how we represent the Cartesian product of M cross N union P. N union P. This is how we write, mathematically write the property is equal to M cross N union M cross P. So this is a law. Distributive property of Cartesian product of two non-empty sets over union. Over union. Since it is a distributive property, it involves, say, three sets. Now, while we want to find out the, say, result for this, how do we evaluate? Starting with the left hand side. Let's consider the left hand side. What expression is present there? M cross N union P. So now what you have to do is that you need to finish the expression, mathematical expression within the parenthesis first and then find the Cartesian product of M cross that answer. So now you find N union P. What is N union P? Write down the set N with the symbol U, union symbol, followed by the set P. What is union? You are going to combine both the set elements. So first write the elements in the first set. So it is 5, 10 and then followed by the elements in set P. What are the elements? It should not reoccur. So what are the elements? It is 1, 3, 5 is present, already present in the set, and therefore we do not write it once again. So this is N union P. Next, moving on to the Cartesian product. So M cross N union P is equal to, first write the M set, which is nothing but 2, 4, Cartesian product of N union P we already found out. So what is it? It is 5, 10, 1, 3. So how many elements you will be having in M cross N union P? It is nothing but the cardinal number of N of M into the cardinal number of, come on say, cardinal number of N union P. So what is the answer? M cross M, you have two elements, into N cross N union P, you have 4 elements. So totally you will be having 8 ordered pairs in the Cartesian product. 8 ordered pairs in the Cartesian product. Okay students, what are the elements of this Cartesian product of M cross N union P? Shall we find out? you have the set here. Okay, so you have to pair them. So if the first element of the pair will come from which set? It will come from set M. So what is it? It is 2. So it is 2 comma, the second set will come from the union set, which is nothing but 5. So 2 comma 5 comma, once again remain with the same first element of M. It is 2 comma 10 until you finish with pairing with all the elements of the union. Then 2 comma, say 1, 2 comma 3. Then since it is completed, move on to the second element of the first set. Second element is 4. So 4 comma 5, 4 comma 10, 4 comma 1 and 4 comma 3. So you see that there are 8 ordered pairs in this set, which is nothing but M cross N union P. Moving on to the right hand side of the expression. What do we have on the right hand side? It is nothing but M cross N union M cross P. So I have already written it on the board for you. M cross N is a set which consists of ordered pairs like this. Likewise, M cross P consists of the ordered pairs like this. So I have found out the ordered pairs, answer for M cross N and answer for M cross P. Both these I am going to find out the union. So just look at this one. So M cross N union M cross P is equal to, first write those elements that are present in, say, M cross N. So what are those elements present in M cross N? 2 cross 5, 2 comma 5, 2 comma 10, 4 comma 5, 4 comma 10, and then before starting to write the elements of M cross P, see whether the ordered pair is already appearing in the answer. 2 comma 1, it is not there, so write 2 comma 1, and then 2 comma 3 is not there in this answer, so it is 2 comma 3, and then 2 comma 5, it is already there, so don't write it, should not repeat. And 4 comma 1, it is not there, so write 4 comma 1, and then 4 comma 3, is it there? No, it is not there. 4 comma 3, and then 4 comma 5. 4 comma 5 is already present there. That's it. So we have finished with, say, M cross N union M cross P. Check for both the inequalities, both the left hand side and the right hand side. We see that left hand side, hence it is being proved. Hence proved. And what you have proved? You have proved that left hand side is equal to right hand side. Okay students, for what purpose are we studying about Cartesian products here? This Cartesian products, say, definition will be applied in relations and functions that we are going to see next. So I hope you know what is a Cartesian product of two non-empty sets. And as I told you, you can find out the Cartesian product of any number of sets.